All right, I believe we are live. So, welcome to World Quant Office Hours number 4, Unit 1. Hope everyone is doing fine today. It's not quite Friday, but it feels like Friday. I guess that's what happens when the last day of office hours of the week is a Thursday. Thursday kind of has a Friday feel. Okay, let's see who is joining us today for office hours. And I see Denenuola. Sorry if I mispronounced your name. Denenuola. I'll try my best to pronounce your name. Welcome. Hello. You're the one with the geology background, I believe, correct? I see Bismarck is here. Glad to see you are back. Oh, it's Independence Day in Nigeria. Okay, I'll look that up. Perhaps I should read up Wikipedia article on Nigeria and get a little more about the background and Independence Day. So thank you for pointing that out. I see Owen is here, Alvin is here, Timothy. Oh, I remember Timothy. Hello, Timothy. Nice to see you. I see Tayo is here. I see Anselma is here. Hello. Hope everyone is doing fine. Okay, who else is joining us? I see Ezyagor is here, Tom is here, Colette is here, Timothy, once again. See you in the chat. Nice to see you once again. Hope everyone is doing fine. I'm doing good. And let's put the agenda here. So just a little bit what I've been doing is I'm in the East Coast of the U.S. But I've been leading a training that for a company based in Europe, but with European hours. And it was a 2-week training, so that required me to be up and ready to teach at 4 a.m., going all the way to noon, my time. So that was a little bit interesting and different. I've had a slightly different schedule. I was going to bed around 7:30 p.m. And tomorrow was the last day of that training. So I'm looking forward to going back to a regular sleep schedule. Living in East Coast time and being in the East Coast, because the past 2 weeks I was under European time zone, even though it was in the East Coast of the U.S. So I'm looking forward next week to get back to a regular schedule. No more waking up at 3 a.m. to get ready to teach at 4 a.m. So I'm doing fine with that regard. I got used to it, but I'm definitely looking forward to going back to my regular sleep schedule. See, Lyndon is here, Fabi is here, Anaya is here. Hello, guys. Hope everyone is doing fine. One of the things I want to do for today's office hours is take a crack at the first mini project. Let's see if we can answer perhaps the first 2 questions, discuss strategy, see different alternate solutions, different approaches. I do want to do that take a crack at the first mini project today. And with that said, if anyone has anything they want to put on the agenda, let me know so I can put it on the board. But I'm going to put here IP mini project. So at some point today we can take a crack at that and start making progress. Don't forget, we do compile a playlist for these videos so people can view them afterwards. And we also create a thumbnail where we put the main topics for that day. So it makes it easier for you to navigate and figure out what is the appropriate video to watch. I see that Salah Hadini is here. Hello, Salah Hadini. Hope everything's going fine where you are. Okay, so let me know anything on the agenda for today besides taking a crack at the first mini project. Anything you want to discuss, bring up, we can put on the agenda. All right, thank you. Are you enjoying the lectures? Someone is asking about recursion. Okay, I'll put that on the agenda. I would say when it I say recursion is probably one of the most confusing things. It's a little weird to think about. We could talk about recursion. Someone's asking about functions. All right, functions. You can always combine these two topics together, talk about functions and talk about recursion. Anything else they want to throw on the agenda? Hello, Subham. Nice to meet you. Anything people want to throw on the agenda? Recursion, functions, I can combine those two things together. Uchenna, hello. Glad you are with us for office hours. What agenda, what are the topics we wanted to throw out there? Besides functions, recursions, and a crack at the IP mini project. Okay, there could be additional topics people want to bring up. I'll just throw on the agenda as time goes on. So let's go ahead and go into data course. I'm going to go into the office hours directory. And this is a directory that I have on my pod that I created where I put these office hours notebooks. And by the way, I will point out that these notebooks I do make available. Someone is asking closure programming. So I'll put that there. Closure programming. Closure programming. And a topic about study further mathematical topics we are using in Python to solve, like do we have to study the fundamentals, for example, Fibonacci numbers, math, example, Fibonacci, and shed more light on iterations. All right, I'll talk about iterations. I think we have some good topics here. Iterations. And how can I get a specific function definition from a package such as stats model API? So we can say specific function from stats model.api. All right, we got a lot of topics there, so let's go ahead and start taking a crack at it. So looking at this, looking at the agenda, I like to see how I can combine topics. So definitely what I can do is talk about iterations along with functions and recursion, and that might set up the stage for future discussion on closure programming. So that's what I'm going to go ahead and do for today. Let's see, I'm going to my server. Looks like that shut down. I'm going to go into data course, office hours, and I do make these notebooks available. I think I was mentioning that. I lost my train of thought. If you go into video downloads, there is a notebook, there is a folder I have on the shared drive that contains these notebooks that I create during office hours. So I do encourage you to follow along. I know sometimes it's a little difficult to kind of type and watch something at the same time. No problem. The notebooks are available in the shared drive. So I do upload that shortly after the end of office hours. So with that said, I'll go new Python 3. Today's date, which is October. It's already October. October 01. I think I call them OH 2020. All right, so let's talk about iterations. And in Python, there are certain objects that are iterables. And all iterable means is that you can iterate through that object. That object contains a series of values such that you can iterate through those values. So an iterable is a broad term, and there's various types of iterables. A list is an iterable. A dictionary is an iterable. A set, a tuple. Those are iterables because you can iterate through them. And what all those things that I mentioned share in common, and those aren't the only iterables we have. There's a lot of iterables in Python. What they share in common is you can think of them holding some discrete value. A list is a box, a container, where you have positions and stuff stored in those positions. Right? We can picture a list. We can have like a box. I like to picture a list like a box. A box like this with things contained in it. 1, 2, 3. Could even be a string like A. Could really be anything. So there are two ways we can iterate in Python. We can use a for loop, which is sort of the preferred way and most of the time makes sense. And a for loop is going to allow you to do something for every value of a container, every value of an iterable, hence the name for loop. Let's go ahead and sketch that out. So in other words, I can create my list, a very simple list, 1, 2, 3, and maybe a string A and a string B. And what I'll do is I want to iterate through every value. Because for example, maybe I want to iterate through every value and print it out. I want to print out every value contained in that list. So what I'll do, I'll say for some variable name which will take upon the value of each thing in the iterable. So in other words, I can say for x in my list, colon. Hit enter. And then indented with respect to the for loop is the code contained, is the code we want to do with each value of the, in this case, my list. So in other words, if I want to print my list, I would say print x. So x would take upon a value of 1, then 2, then 3, then A, then B. I'm going to print x out. So for every value of our container, for every value of the iterable, we are printing it out. 1, 2, 3, A and B. Questions about this iteration here? I see there's a new agenda, brief discussion on GitHub. Yeah, I'll throw that in there. And I think we can make a broader here and talk about Git. Since GitHub is just a website where you can host Git repos, the broader topic would be Git. Yeah, so X can be any name. Correct. X can be any name. However, typically Python stresses readability. And one of the things you want to do when you work on your programs is you want to make sure your code is readable. So here, you know, my list does not really contain anything, so I just kind of use X as a generic value. But what if I had something like, I don't know, file paths? Maybe in here I had path to some data. Maybe I have a directory and I have maybe file, maybe some first CSV file. And maybe I have another CSV file. And a string that represents a location on my computer of a CSV file. So I call that list file path. So it's very clear when someone looks at this code, they know what that is. Oh, they're file paths. It's a list of file paths. So when I want to iterate through those file paths, like for, I could use X. I could use anything really. But maybe something might make sense if I say file path in file paths. And then I say, in this case, I'll print file path. But you can imagine maybe in this block of code, I would read that file and do something with that file. So when I look at my code, I don't have a variable called X. What is X? It's not so readable. I really mean, sorry about that. Makes my code more readable. So yes, it is arbitrary, but let's choose something that makes it readable. We'll make sure we do that in when we work through the mini projects. Any questions people have at the moment? Okay. Now let's talk about functions. Let's move on and talk about functions. I'm going to go ahead and by the way, for this agenda, I may not get to all these topics today. But what I do is I keep track of this agenda. And I keep track of it so that in future lectures, I say, okay, someone did bring up, let's say, Git. And then maybe I can look at that and at some office hours, some point in future, come into office hours with a little mini lesson prepared for Git. So if I don't get to it, don't think I've ignored it. I just going to head, maybe introduce it some later time during the course. So I'm going to go ahead and scratch out iterations, and we'll see plenty of iterations later as we get more practice. So I'll scratch that out. Someone's saying, are we to complete all materials on data structures before the week ends? There really is no deadline, really. There is no weekly deadline. However, I do encourage you to kind of keep track of the videos we post every week. And let's see. Yeah, so you don't have to complete all the materials on data structures, but I do encourage it so you can kind of keep pace with the course. But there really is no deadline. All right, I see Avi is here, and they are an alumni of both units. Hello, Avi. Hope you're doing fine. Okay, I see Peter is here, so hello, Peter. Okay, and Salah, I see you posted some code. Do you have a question regarding that code? What is it? Okay, I see something of plus equals and minus equals. I can throw that in the agenda. I'm doing fine. I am doing fine. I'm doing good. Yeah, I'm doing pretty good. Okay, so let's say we have a variable, and we'll call it, I don't know, we'll call it count. It's keeping track of something, some counter in our process. And maybe we have something like, well, we want to augment the value of count by a value of 1. So we could say count is equal to count plus 1. And that right there gets a little tiring to write out. So instead, we can write out the equivalent count plus equal 1. So this here is the same thing as saying count equals count plus 1. So that's what this plus equals means. If I had something else, I can say count plus equal, let's say 3. Well, that means the same thing as count is equal to count plus 3. We have other things like minus equal. Let's say minus equal 5. So what that means, as you can imagine, is count is equal to count minus 5. We even have star equal. Let's say negative 1. And what that means is we have count is equal to count times negative 1. And someone is asking, in what situations would this be useful? Well, a situation where this would be useful is maybe you have a list of words. And maybe you're trying to do some analysis of you have a list of words and you're trying to figure out how many times each word appears. So let's say I have apple and orange and apple again and banana. And I want to figure out how many times each word appears in this list. So what I could do is what I basically want to do is I want to use a dictionary, because here makes a perfect example of the power of a dictionary. Because with the dictionary, I can map the key, in this case apple, orange, or banana, to its occurrence. So I can call this words, and I can say create a dictionary called counter. And what I can say for word in words, I'm going to first check if word is in my counter dictionary. Then what I want to do is I want to augment its count. So I say counter, and I index that word. It's that key, or that value for that key. And I say plus equal 1. Else, if that word isn't in the counter, then that means I need to create a new key value pair. Let's go and print out counter. And sure enough, I've generated a dictionary that contains how many times each word appears in this list of words. So here I make use of iterations. For word and words, here I'm using readability. I call my list words. So I call the variable of iteration of the for loop word. I check if it's in the dictionary. If it is, let me augment its count by 1. If it isn't, I will go ahead and create a new key value pair. So here I could have said counter word equals counter word plus 1, but this is a nice convenience that's often used. Someone is saying, would count / equal 1 work? Yes. Yes. That would work as well. So in other words, count / equal 1 is the same thing as saying count is equal to count divided by 1. Exactly. I left that one out, but that works just as well. Let me know if there are any questions about this example here where I use a dictionary, iterate through list, use a +1 equal. And then we'll jump into functions. I'm going to go look at the chat here, make sure I'm taking care of some of these questions that are bringing up. All right. Okay, and Umang is asking me a question about going from teaching to data science. And I would say, yeah, the answer is yes. I would say the answer is yes. You have a strong background. It's very important. A lot of people like data scientists who have a computer science background, and that's what you have. So now it's more of developing those data science skills. So you're in the right place, I would say. I think a lot of times the interview process for a data scientist involve computer science questions. So given your background, you're going to be at a plus there. Okay, let's see. Someone's saying with the playlist for this, and if you go here into your pod, at the very bottom here, there is the office hours playlist. That's what we have right there. In fact, I'll copy that and I'll paste it in the chat right there. All right, someone has asked me if I can please explain this again, and I will. So what I want to do is I want to keep track of how many times each word appears in this list. So here's a perfect example of using a dictionary, where essentially I want to have the key as my word and the value as its count. So I have my list here. I have an empty dictionary. So here's an empty dictionary. It's there to create key value pairs. And what I do here is I iterate through every word. So I'm going to actually print word out so we can see what happens as I go through this for loop. So as I go through this for loop, word will take up on the value apple, apple, orange, apple, and banana. And then I have an if statement. I check, and I can put some code here, a comment to explain what's going on. Here I am checking whether, I'm not even sure if I know how to spell weather these days, whether the word exists as a key in the dictionary. And what I'll do is also I'll print out my counter. I'll print out that dictionary for every pass so we can see how it's changing and growing. If it is already in my dictionary, then all I want to do is update the value for that key. And that's what that plus equal does. It's going to update the count. So if I see it, then I'm going to update its count so I can keep track of how many times it occurs. If it isn't in my dictionary, that means I need to create a new entry in my dictionary. So here I create a new key value pair. See Vera's here. Hello, Vera. Let me run this here. So for the first pass, word is equal to apple. We have an empty dictionary. And then afterwards, we're apple again. But now our dictionary already has apple with a count of 1 since we've already seen it once. So now we have orange, and our current dictionary is apple 2 because we've counted it twice, and so forth. So we're keeping track of this dictionary, keeping track of how many times each word appears in this list. Further questions before we improve on this? Someone is saying, when you define a dictionary as a curly braces, is it by default a default pair of values, name, counter, or are there any variations in the structure? Yeah, so when I create this dictionary here, it is empty. There is nothing in it. However, keep in mind that dictionaries store data as key value pairs. Your dictionary stores data as key value pairs. It's just that when we create an empty dictionary, there is no key value pairs to begin with. So we will add them later. So in a dictionary, you always have a key associated with a value. Yeah. Someone is saying, can you write comprehensions for this? And the answer is, let me think, can we write a comprehension for this? Let me think. I think the answer is no. I think the answer is no here. I don't think it's possible to write a comprehension version of what we did here. Okay, other questions people have? You can think of a computer program as its very core, the building blocks are variables. You take a look at some program and some code, it makes use of variables. The other building block of a program or a piece of code is a function. And functions are nice because they encapsulate some process, some set of instructions, so that we can reuse those set of instructions anytime we require it. And I like to think about a function as a recipe. It is a recipe that takes ingredients at times, and every time we follow that recipe, we create something or something happens. So this here, this process here, imagine we had to do this again, but with a different list. What I could do is I can go ahead and copy this code, paste in a new cell, and maybe I have a different list. Maybe my list is things like car, bike, car, train. I could copy and paste the code and repeat it again. However, this isn't so great because one of the key principles of computer science, of good programming skills, is called DRY. Do not repeat yourself. Do not copy and paste. Do not have code that's repeated, because one of the reasons is, I don't know about you, but every time I copy and paste, I tend to do a mistake. I always forget something. I forget to change some variables. I would always do some sort of mistake. The other reason is because if there's a problem with this code here, and I fix the problem, I have to remember that this code is duplicated elsewhere. So it'd be very nice if the functionality is located in one central place, in one function. So let's go ahead and do that. Let's take this code and wrap it around a function so we can make use of it anytime we require. So what we'll do here is I'm going to go ahead and define a function. I like to define my functions to have verb-based names, because you can think of functions as doing something. So let's make it have a verb name. So I'm going to call this, any suggestions about what we should call this function? And what I want this function to do is I want it to return a dictionary that tells me how many times each word appears in the given list. Let me know your suggestions on the name of the function. Readability counts. Let me take a look at the chat here. Someone's asking about a good data science book, and I will put here in the message a book that I like that is free, and I will post this in the chat. Okay, word counter. Someone's saying suggest word counter. Yeah, we can say word counter. And we're going to use, Python has a convention, a style convention. And let's try to follow that as much as possible in this course. And the reason why is because if we all use the same style, then we make our code very much readable, more readable. So I'll call it word counter. That's just the first suggestion. That was good enough. And Python convention is that we have things named in lowercase. We'll talk about custom classes later, and that has a capital letter. But for the most part, we name things in lowercase, and we separate two words using an underscore. This is called snake case, because I guess it's supposed to look like a snake. I don't know. As opposed to camel case. So here we define a function called word counter. So define this function, so that's the name, and in the parentheses are the ingredients of the function. What does the function require to make it run? And what this function requires to make it run is a list of words. So I'll call this the argument words. So now what I do is I'll just bring all this code inside the function. Notice it's indented with respect to the function, so it's a code that belongs to the function. So we create the empty dictionary, and I can just remove these print statements because they're more for us understanding what's going on. And at the end, we return counter. So what we have, the return statement is what is returned when you call the function. What does this function spit out when you call it? I like to think about functions as a machine. Here is our machine. And it spits some output out. And our machine accepts a list of words. It does whatever it needs to do, and it spits out a dictionary. So now I'm going to define this function. Define this function here. I have an indentation error. So when I have an indentation error is meaning that something should have been indented. Forgot about indenting that line there. All right, so I ran this cell here. So what has happened is nothing has really happened except for I basically have written down my recipe. I haven't baked the cake yet. I just simply have defined how I make the cake. So someone can go ahead and make the cake themselves. I've simply defined a set of instructions that belong to the function. So now if I want to make use of the function, or in other words, I want to call the function, what I say is word counter, the name of the function, open and close parentheses, and what goes in is the input to the function. So word counter, I'll call this word transportation. Words transportation. Give me the counter for words transportation. I'm using tab autocomplete, by the way, in Jupyter Notebook. If you're wondering how I type so quickly, it's because I use tab autocomplete. WO tab, all the list of possibilities. I'm interested in words transportation. I run that and I get my output. I get the output of running this recipe for this set of ingredient. So this is nice because if I had another list, I'll call this words animals. I say fox, and I have bear here, and I have wolf, and wolf, and wolf, and bear, and fox, and bat. I don't need to copy and paste. I can simply call my word counter function. Hey, word counter, give me the counter. What's the input? What's the ingredient? Words, animal. Okay, any questions about what I did in this function? Wrapped it around a function. Okay. Notice when we ran this, we didn't assign the output to anything. So when we use eFunctions, since it returns an object, we can say something like animal counter. Say animal counter. And here we'll call it transportation counter. And we can go ahead and print transportation counter. So we'll see we assign the output to variables so we can make use of them in some other downstream process. So questions about functions before we move on. Okay. So go ahead and scratch that. Functions. Scratch that from the agenda. Now let's see what else we can take a look at. All right. And I think might be... All right, someone's asking how to iterate values over a dictionary. All right, so we can say for... When you iterate through a dictionary, you iterate through the keys. And this is crucial because with the key, you can get the value. And remember that the mapping is one-to-one. In other words, the mapping is one directional. You have the key, you can get the value. If you have the value, it's difficult to get the key. So when we iterate through a dictionary, so for key and animal counter, what we really iterate through is the key. Okay, and there's a question about scoping, which is related to functions, which are a great topic, so I can talk more about that just after I answer this here. So for key and animal counter, I print out the key. And of course, this is arbitrary. Could have been anything. Could have been animal, right? Since we have our keys are animals, I can say animal and print out the animal. And since I have the key, I can print out, I can say print animal and animal counter animal. Since I iterate through the keys, for a given key, I know how to index and pull out the value. Someone is saying, can we use a function inside another function? Yes, you can. That is very common. One of the things you want to do when you construct your programs is sort of separation of concerns. Don't have one function that just does everything. You can very much call another function inside a function. If you want to iterate through both the key and the value of a dictionary, key, value, and dictionary, you're going to use the items method. The items method gives you an iterable where you can allow to iterate through the key value pairs of the dictionary. So I'll print out key and value. So I'll put a little message here. Iterate through key value pairs. And here we iterate through the keys. It's a question about scoping. So let's talk about scoping. Now in this function here, notice we have a variable called words. However, we already had a variable outside called words. I think we called it, where was it? Right there. So when we run this, so we have this variable called words. But in here, we have a variable also called words. So which one will it use? Will it use the one that is global, in other words, outside of the function? Or will it be used the one that's provided inside the function? Will we use the one outside the function or inside the function? What Python does is if you reference a variable inside a function, what it checks is there a variable with that name inside the function? If there is, that's what it uses. So let me just show you that. Define, I'll call very simple function, my function, accepts two arguments a and b, and it creates a variable c equal to 1, and it will return 1a plus b plus c. Before I have that, I already define a and b and c. These here are global. These here are called global variables. So in this function here, which value of c will it use? Will it use the value c from inside the function or the one that exists outside the function? We'll use the global one or we use the one that's defined in the function. And the way that Python resolves this, it says, hey, let's first use the one that's defined in the function. If that one doesn't exist, then we call upon the global one. The way I like to think about it is, think about a function as a recipe. You're cooking in the kitchen. If there is something that doesn't exist in the kitchen, you first check in the kitchen. If it doesn't exist in the kitchen, then you go outside the kitchen. You don't want to have to leave the kitchen. You don't want to do that, right? It's annoying. You have to go and leave the room, and you don't want to cause a fire, right? So the first thing you do is you check inside the function, inside the kitchen, and then you check outside. Same thing in Python, exactly, inside the function. So this here, if I define this function, I call my func, and I say 1, 2, and 1 and 2, then I should get a value of 4. I get a value of 4. Because it took upon this value here defined inside the function. But now let's see a scenario where my function doesn't define c. There's no local variable inside the function with the name c. So my function, I'll call it alternative, an alternative one. And what that does, it returns a plus b plus c. Define that function. So when I call that function, pass a and b as 2, since c isn't defined in the function, Python says, oh, I don't see c defined in the function. I guess I'll have to look outside the function. Is there a global variable with the name c? And that should get us 2. Because sure enough, there was a global variable with the value c, with the name c. Now, if I make use of a variable that isn't defined in the function or outside the function, then we'll get a name error. Get a name error because it doesn't exist. Word of advice, I would stick away from global variables. They can cause a lot of problems. Hard to keep track of state. Someone is asking, all right, hopefully that answers your question about scoping. I can put that in the agenda so I know that it was talked about. Here, scope. All right. Someone is asking about a WhatsApp group, and there is one. It's not an official WhatsApp group, by the way. I will have to emphasize that. But if you go onto the forum, and I'll post a link to the forum here, there are people who have posted links to a WhatsApp group that they've created. It's not an official WorldQuant sponsored WhatsApp group, but there's informal groups that people have created. They're in the forum. Look at the questions. There's one about WhatsApp group or something like that. Take a look at it. Okay. Take a look at this. And we talked about scoping. Okay. Clojure programming might be a good topic for in the future. I think I can cook up an example of decorators and what they are to build upon some of the top things we talked about functions. So decorators. Okay. What I want to do here is let's take a crack at the first mini project. I might just do one question, but let's get some practice on it, discuss some solutions. We go into Python mini projects. Let's open up the IP mini project. All right, so let's run the grader. Let's import the grader so we have available to use the grader. And now we know about functions. We can go ahead and take a crack at the first mini project. So we see here that a Mersenne prime is a number. A Mersenne number is any number that can be represented as 2 to the p power minus 1 for some p. So for example, if a p-value of 3, then we can say, 3 is a Mersenne number because we can have 2 to the squared. 4 minus 1 is 3. 31 is also a Mersenne number because 2 to the 5 is 32. Minus 1, 31. So let's define a function that will generate these Mersenne numbers given this equation right there. What we could do is just follow the formula. So in Python, the way we use powers is star star. It's not a caret like other languages, it's star star. So let's raise to the p power and we do minus 1. So now we have a function to calculate Mersenne numbers. So now we define the function. Let's make use of it. Let's say Mersenne, let's a value of 2, which we should come out to be 3. Let's see what that is. Returns 3. Well, let's try 5. 2 to the 5th power is 32 minus 1, and this should be 31. And sure enough, this appears to be working. Okay. So now, with this function here, what we want to do is we want to see which numbers are prime. So what we do here is where we say, look at this notebook where we get a prime function. So I'm just going to copy and paste what's in that notebook. Put it right there. So now we have two functions that can help us out here. We have a function that will check if a number is prime using a rather crude approach. Yes, it will be able to tell us if a number is prime, but it's not going to be as fast when we get to larger and larger numbers. It doesn't have a good time complexity. However, it will tell us whether a number is prime. And then we have a function called getPrimes, which will return to us, we put a dot string here, return all the primes from end start to end end. So this uses comprehension to generate this list here. So use the range function to give us an iterable from the start to the end position. And what do? Is we filter, we check, should we filter it out? So is it prime? If it is, then we include it in the resulting data structure we create. I have a syntax error because I have a dot there. I don't know why that happened. Run that cell there. Now let's test this out. I have an is prime function. I can try 17, which I know is prime. That returns true. 31 is also prime, but 21 is not. It's a composite. False. Let's go ahead and try the get primes function. You say 1, say 2 to, let's say 100. We take a look at that, and looks like we have indeed prime numbers from 2 through 100. Questions people have about what we've done so far? Okay, so now we can go ahead and get a list. How can we have a function without parameters? Yes, we can. I expect the else in is prime function. Oh yeah, so I have a couple questions here. Can we have a function that doesn't accept parameters? And the answer is yes, we can. For example, I'll just show you here my function accepts no parameters, but for example, maybe this function go ahead and gives us maybe gives us odd numbers. So for for num in range of 100, if I divide it by 2 and is equal to 1, then include that. So very much I can have a function that doesn't accept any arguments. So there's no input to it, but it does generate something. This is perfectly valid. This is odd numbers. And I probably would call this odd numbers. Right, let's use something. Find odd numbers. I can call find odd old numbers. Oof, numbers. Someone is saying, I expect the else in the is prime. If I go to the is prime function, we don't have to have an else here. And the reason why is, let's go ahead and look at this line, how this code works. It accepts a number, and if we check if it's less than or equal to 1. If it is, we return false. 1 is a special case. It's not prime. It's its own little thing. And what we do is we iterate through all the factors, and we check if it's divisible by that factor. So if it is divisible, then by definition it's a composite number, so we return false. But we want to check. We don't want an else statement necessarily, because we want to check all the possible factors. If we have gone through all possible factors and we've yet to return any value, we exit the for loop and we return true. The else statement is great if we want to do something if the statement isn't true. But we want to make sure we go through all the values. If we had said else true here, which is wrong, what this would mean is that if the first condition, the first time we encounter a false, then we return true. But we haven't checked all the other conditions, all the other factors yet. So we don't want to have else. We want to reserve the return true for later. So remove that there. Okay, let me know if there are any follow-ups. But now we have a function that calculates these Mersenne numbers. And now what we can go ahead and do is use those two functions to construct our answer. So we want to go ahead, and our approach here is iterate through a p-value of 3 to 65. So sorry, we want to to get all prime numbers through 3 to 65 and generate its respective Mersenne number. And put everything as a list. So we can say for, let's do this without comprehension. So I'll create a variable here called Mersennes. Make it blank. What I can do is I can iterate through prime and get primes 3 to 65. So here's going to give us all the primes from 3 to 65. And what do? We call upon that recipe Mersenne number, pass it prime, and we can append this to this list called Mersennes. So we iterate through all the primes from 3 to 65. And for each of those, if it's prime, then we are constructing the respective Mersenne number and append it to that list. So what do you mean by factors here? Yeah, so what we do is we examine this function here, where is it? This right here, is we are going to test whether a number, the way this works is, let's say we want to test whether the number 100 is prime. We know it's not prime, but let's say we don't know whether it is prime or not. Is 100 prime? One brute force approach to check whether it's prime is we're going to divide 100 by all possible numbers from 2 all the way to 99. So 2, 3, 4, 5, 6, 7, 8, 9, and 10. All the way to 99. So we're dividing by what I call these factors. We should probably call it divisors, or probably a better name. And sorry if that confused you. We should probably call that divisor. For divisor, I think that's a little more readable. Maybe that confused you. Sorry about that. And we're doing exhaustive approach. We're dividing 100 by all these numbers from 2 all the way to 99. Because if we find one case where the number is evenly divisible, if 100 is evenly divisible by one of these, then by definition it's a composite number. It is not prime. And sometimes we can find that right away. 2 divided by 100 is 50. It's evenly divisible by 2. So it has no remainder. It has no remainder. So we know it's not prime, so we automatically return false. No need to search through the rest of the numbers. All right, so now we know how to get the Mersennes, our answer list, but we haven't done this via list comprehensions. So let's go ahead and try to do this with list comprehensions. And the way I like to write about, treat list comprehensions is that you can think of lists or comprehensions in general. It's all about generating a new data structure through iterating through an old one. And there's 3 things that contain in the list comprehension. You can think of the comprehension is we have the for loop for blank in some data structure. What follows this for loop is a filtering condition, some sort of filtering, which is optional. And then what goes in front here, I like to call this the recipe. In other words, how do we construct a member of the new data structure through the value of the old data structure? So in other words, if we wanted to construct a list of the square of all the odd numbers, I would say for I in range of, let's say, 100, and if I divided by 2 is equal to 1, then how do I construct the new member of the data structure? Well, I square the value. This will give me the square of all the odd numbers from 1 to 100. So then with that said, I can go ahead and construct my answer using comprehensions. I can say for prime in get primes from 3 to 65, there's no filtering I need to do. And for each one, I will call the Mersenne prime number function. And I'll assign this to a variable called Mersennes. And we'll just verify that, and I believe that appears to be the correct solution. And now what's next is just submit it to the grader. All right, we're at the end of our office hours. Any questions people want to bring up, I will keep track of this agenda so I can have it for future office hours and be prepared to talk extensively about things like Git, decorators, recursions, and so forth. So yes, I do keep track of this agenda, so don't worry. Any last things we want to introduce before we close office hours? All right. Well, guys, take care. It was the first week of WorldQuant. Take care. Have a good rest of your day and have a good weekend. We'll see you next week. We'll pick it up with some more of the topics people throw, some of the stuff that's on the agenda, and make our way more and more through the mini projects. So with that said, guys, take care and see you next week.